first session of Electromagnetic Induction, and this is your Sprint series with me, Shreyas. And today we are going to talk about how electricity can be created using magnetism. We are going to talk about flux changes. All these concepts are going to be used. We are also going to see Faraday's experiment, and we are going to see how magnets and coils can create electricity. And we are also going to see the working principle of a generator. All this with me, Shreyas, your master teacher for physics at Vedantu, and I'm going live. Welcome all the minions. Hello Aishwarya, Aarti, Yalni, Siva, Sneha, Karthik, VK channel, Science Priya, Anish, and everyone else out here who has not yet posted their comments yet on the live chat. Come on guys, go ahead, post your live chats, because that's the only way you can mark your attendance, and that's how I will know and other fellow minions will know that you guys are here. Come on, say hello, greet each other. We are a very lovely family of minions, and we all have the same aim to crack the JEE examination with really good score, and also to develop interest in all these subjects that are being taught out here. We are going to have fun while learning. It's not the same old traditional method that we follow over here. We interact, we want to form the bond with you, and that's why we are here. Hello Arsoria, hello Rustam, hello Dinanath, hello everyone. Glad that some of you are back after a long time, and yes, let's rock Karthik. Why not? Hello 79s, hello Ruba, and a lot of new timers out here. So guys, this is Shreyas here, your anchor for the channel and also the master teacher for physics, and I also do teach in the regular batches at Vedantu, and I have been teaching for almost a decade, producing some amazing results in the JEE Mains and JEE Advanced. I have mentored many students, guys, like probably this number should change by now. And anyways, many of my students are right now in IITs, NITs, BITS, ISER, IIST. These are all the top colleges of our country, and they are doing extremely well. And guys, if you want to get more updates, if you're a new user out here, you should first hit the subscribe button. It is free of cost. Come on, go ahead and hit the subscribe button. And if you're already subscribed to our channel, you know what to do, guys. Go smash that like button down there, because unless and until you smash that like button, YouTube is not going to recommend you more videos of ours. And also, we are not going to get the energy for conducting more sessions. Come on, go smash that like button. Hello everyone. Welcome, welcome, welcome. So Aishwarya, regarding the 75% criteria, it's not clear, but it seems like it's gone away. I think they are doing away with that 75% criteria for JEE Advanced. As long as you have qualified JEE Mains, I mean, I think if the criteria for JEE Mains, if it is, let's say for example, 65%, then the criteria automatically applies for JEE Advanced, because come on, without clearing JEE Mains, you can't clear JEE Advanced. That's an indirect way. But there is no such criteria as such, but more clarity will be given to you by Shimon sir at I think 9 o'clock. He's going to conduct a lecture. All right. Welcome Siva, and glad you are new to this channel, and I hope you will be consistent like every other student and minion out here. So yes, Anand, I will definitely launch JEE Advanced question series very soon, but first I want to get done with the basics. I want to get done with KVPY next week, and next week there are going to be lots of KVPY series questions and sessions for all of you, and the week after that I'm going to again come back to JEE Mains and then JEE Advanced. So we're going to have a lot of things. And Anand, there is a special batch only for JEE Advanced, yes, and JEE Mains, that's called Ekalavya batch, and there is crash course. I'll be giving you all the details, so stay tuned guys. Yes, so any other doubt guys? Hello Joker, hello Pramesh, everyone. Any other doubt you have, please post all your queries on the comments section, because during the live session maybe sometimes I might not be able to answer all your doubts. So please post all your queries in the comment section after the video ends. And thanks for all the love and support you have been giving me. And if you want to still ask me something, you can also ask me on my Instagram handle, and that is nothing but Shreyas_Vedantu. So that's my Instagram handle. You can go follow me there. You can ask me anything that you would like to ask me. All right. So this is the week schedule. We are nearing the end of the week. So today we're going to start with electromagnetic induction. Tomorrow it's a marathon session. Be careful. It's a big session. Today is a very short and sweet session. And Saturday KVPY SX, capacitors and current electricity related questions on SX. Alright. So that's for Saturday. All these lectures are at 7 o'clock unless specified otherwise. And on Saturday in the morning you have Menti quiz. So come prepared in the morning. Do not forget to wake up early on Saturday. Come on, this weekend. And Sunday you have chemistry Menti quiz at 9 o'clock. Hello Vishnu, hello Sneha. Welcome everyone. Welcome, welcome, welcome. So, very good Pramesh. Congratulations. Congratulations. All right. So any other doubt that you guys have, please post it up in the comments or send in the query to me on my Instagram handle. So let's begin, guys. Now the first thing that we need to understand for electromagnetic induction is magnetic flux. Remember, we have spoken about electric flux in current, electricity and electrostatics chapter. Similarly, there is a quantity called as magnetic flux. Now, if you have the poles of a magnet or if you have a coil carrying current, it produces magnetic field. The number of lines which pass through a given area or an imaginary area is basically called as flux. Flux is nothing but flow, guys. So flow of something. Magnetic flux is flow of magnetic field. Electric flux is flow of electric field. So how much field lines or how many field lines are flowing through a given area is called as magnetic flux. Naturally, it should be proportional to the number of field lines which are piercing a given area. So if I take that area, how many lines pierce through it decides the flux. More the number of lines that pierce, more the flux. Also understand, if the area and field lines are parallel, that means the area is like this, field lines just go over it or below it. Nothing actually pierces through it, then understand the flux through it is zero. So flux is only there when the field lines actually end up piercing that area and not pass over or under it. That's very important. That's why this word piercing has been mentioned. I hope this is clear. All right. Yes, P dot. I will definitely do thermal properties. I will do everything, but maybe not in the order that you are expecting. But we are going to do everything. Do not worry. Just have some faith, P dot. All right. Don't worry. Okay. Let's concentrate. Now, the next thing that I want you to understand is that the flux depends on three things. What are those three things, guys? Number one, imagine if the number of field lines increases. The number of field lines, if it increases, then think about it. The number of the field strength will also be more. So the flux depends on number one, that is the magnetic field strength. If the field is stronger, more lines will pierce through it. I hope this is clear. I hope this is clear. Next thing, if I choose a bigger area, then the field lines which did not pass through that area will also now pierce through it. If I choose a bigger area. So definitely it also depends on the area that I have chosen. Number one was field strength. More the density, more the field strength, more the number of lines. Number two is the area, and number three is the orientation. This also matters because this same area, if I orient it differently, then obviously the number of field lines passing through it will be also different. All right. Great. I can see all the love and support, guys. Thank you. Anish, don't worry about 11th. I'll tell you what it is. Just message me. I'll tell you what it is. Don't worry about it. Okay. Great. Great. Now, let's see the formula for the magnetic flux. Now the formula for the magnetic flux is, if you have an area and if you have some magnetic field lines passing through that area and the field lines are at an angle theta with the normal drawn to that area. What is that theta measured from? Normal drawn from that area and the magnetic field lines. That's theta. It's not magnetic field with the actual area. It's field with the normal drawn to the area. That's very important. That's very important. So the thing is, the magnetic flux, by the way, the symbol for that is phi. That is given by B cos theta into A. Now why B cos theta? That's very obvious. This magnetic field will have two kinds of components. One which pierces this way through the area, that will be B cos theta, and B sin theta will be like that because they will be flowing parallel to that area. Now think about it, B sin theta has no role to play because that is not piercing through that area. B cos theta pierces through that area, that's why B cos theta into A, and I can write this down as B vector dot A vector. That is nothing but magnetic flux. Alright. Oh yes, Kirito, I think the camera was adjusting by itself for some reason. Okay, let me just check if I have turned off the autofocus. Just 1 second. Oh, 1 second. I think the autofocus was on, my bad. Just 1 second, guys. Thank you, Kirito, for mentioning that. So somebody was just probably saying, hey, yes, something was adjusting. Yes. So now it's fine, I guess. Okay, I hope now it's not adjusting, everything fine, guys. Thank you very much for letting me know. Okay, so now what is the unit? The unit of flux is obviously Tesla meter square, and 1 Tesla meter square is also called as Weber. So 1 Weber is 1 Tesla field passing normally through an area of 1 meter square. That's it. Hello Khushbu, I hope you are fine today. Alright, so that's what you should know. Cool. Let's do a question on this. A magnetic field in a certain region is given by 40 I cap minus 18 K cap. How much flux passes through 5 centimeter square area loop if the loop lies in the XY plane? Come on guys, I want you to think about it. What will be the answer? Come on, think about it. Come on, think about it. Everyone. Yes. Okay, come on guys. Okay, chalo, I'll start solving. Meanwhile, I'm guessing you will start solving the same problem. So first of all, magnetic field is given, but it is given in G. It's not Tesla. So some of you might not be familiar with this unit of Gauss. So let me tell you what is this Gauss. 1 Gauss is actually 10 to the power minus 4 Tesla. So if you do not know it, now I'm telling it to you. 1 Gauss field is nothing but 10 to the power minus 4 Tesla. Okay. Now, this 5 centimeter square converted into meter square. So this will be 5 into 10 to the power minus 4 meter square. But in order to do this problem, here is what I'm going to think. How is this magnetic field going to affect this area? Let's try to think about it. Guys, if this is my X, this is my Y, and this is my Z, the area of that loop lies in XY plane. Okay, very important. It lies in XY plane. XY plane is here. So this is where that loop lies. Now, which component out of I cap and K cap of the field will actually end up piercing? Will I cap pierce or will K cap component pierce? Because I cap component will go like this, and K cap component will actually end up piercing through that coil. I hope this is clear. So it's only this 18 which matters to me. This 40 I cap is useless completely. Think about it. So hence that flux will be the magnetic field, which will be 18 into the area, but that is Gauss, so do not forget to convert it into Tesla, okay, multiplied by the area itself. What is the area? It is 5 into 10 to the power minus 4, and cos theta will be 1, guys. Why is cos theta 1? Because you can see that the area is actually, that area vector is actually making 0 degrees angle. that area vector is actually making 0 degrees angle with that minus 18k cap. Think about it. So cos 0 will be 1. That's how you can think about it. So the magnitude, and anyways, we are only interested in the magnitude of it. So whether it was 0 or 180, it won't matter. So cos 0, cos 180, the modulus of it will be 1. And that's why, what is 18 5s guys? 90. So 90 into 10 to the power minus 8 Weber. So that will be the answer. I hope this is clear. I hope this is clear. Understood, guys? I hope this is clear. Everyone understanding this? Preetham, every teacher's style is different. So I will clear all your doubts as much as possible during the session, but there are some doubts which is not possible during the session, and plus the number of students in my session are large, so I really can't answer everything. So understand, I can clear all your doubts in the comment section or in the Telegram, in the Instagram. Also, if you want to ask something on Instagram, you're free to do that. And also we have pro subscription where all your doubts get answered during the live session as well. All right, I hope you understand that. Great. Up to you. All right. So now, having said that, let's go ahead. Let's go ahead, guys. Come on, let's go ahead. Now, before we talk about Faraday's law and before we talk about Lenz's law, let me make this very important announcement, guys, about the crash course, because the JEE advanced dates have been announced. Yes, the JEE advanced dates have been announced. The JEE mains dates have been already announced some time back. So there is hardly 2 months for the first attempt, and for the next attempt maybe 3 months, and so on and so forth. Can you crack JEE mains? Can you crack JEE mains in these 2 months? Yes. If you have been decently preparing, or even if you are well prepared, but even if you have the slightest of the doubts, whether you know about the confidence you have on your preparation, then please don't leave any stone unturned for cracking the examination, because nobody is going to ask you how many books you studied. Nobody is going to ask you, how many institutes or what did you do during your preparation so much. What matters at the end of the day is which rank did you get. That's all that matters. Whether you do it on your own, whether some institute supports you, it doesn't matter, guys. At the end of the day, you have to get that rank. Understand that. That is what is going to give you that seat in the college. So, understand that this crash course is meant exactly for those people who want to improve in any way. Maybe you are getting out of 300 250 marks. Maybe out of 300 you are only getting 50 marks. It's okay. This crash course will improve your score. And there are 45 sessions planned in this crash course to revise not just 12th but also 11th standard syllabus. So 11th and 12th, both syllabus will be revised. Guys, please don't hesitate to think about it, because there is also going to be live doubt solving with the class teacher and after the class also, because like so many of you had that thing, ki sir, we want our doubts to be solved. Understand, we'll try to solve as many doubts as possible on YouTube. And that's my promise, guys, that we started this channel so that it has to be free, and this will be free even for next year and so on and so forth for all 11th, 10th dropper students, even the 9th, 10th standard students, everyone. It's going to be free. But if you want more, yes, you can get in touch with the subject matter experts, the class teachers, to get your doubts resolved. Plus, what is more important is the test series. So guys, the test series will be conducted in this crash course. So go ahead, check out everything about it. And the course fee is only 8,000 after you use the discount coupon of SHCC. So check out everything about the crash course. Every detail has been mentioned even in the session PDF, which is again there in the description box below. So please go ahead, check it out, and do join at the earliest. Do not miss this train. Okay. Now, yes, Rohan, should you take a drop right now? No, Rohan, JEE 2022 is much ahead. Start preparing for 12th and revise 11th. I'll tell you detailed plan if you can message me on Instagram. Now, or put it up in the comments. If electricity can be created using magnetic field, we have seen that in the previous chapter. If you have a coil carrying current, it creates magnetic field. So, same way, can we create, can we create electricity using magnetic field? I want both the things to be done. So, can I create magnetic field using electric field? Can I create electric field using magnetic field? And the answer to that is yes. And let's see how do we do that. Now, let's think what exactly happened lots of years back and what did exactly Michael Faraday do? Because Michael Faraday exactly had that same doubt in his mind that Ørsted's experiment proved that current carrying wire, which is electricity, can create magnetism. Faraday wanted to see, can magnetism create electricity? So he built an elaborate setup. He had many coils, magnets, everything, voltmeters, ammeters, and he tried it out. Many times. He tried moving those magnets, he tried moving those coils, he turned it on, turned it off. He did everything possible, but he never saw current in those coils or voltage in those coils. He was really fed up. He's really fed up because he has tried for weeks together and nothing has moved an inch. Then he thinks probably maybe, magnetism cannot create electricity. But then understand that, guys, you should try and try but never stop. And that is the lesson you should learn from Michael Faraday today. That is a very important takeaway. It's a life lesson that you should take away from today's session, guys. So here it is. The thing is, he one day found out that suddenly that coil deflected. And he was shocked to see that. He was like, why the hell did that coil deflect? Because so many weeks it did not deflect. What is it that made it deflect? He thought it was some error. And then he realized that his volunteer, his apprentice who used to work with him, had suddenly turned on something on the other side. Then he realized what was the mistake he was committing. You know what happened exactly? All this while, he used to turn on one coil which would create magnetic field around it, and those magnetic field lines would pass through another coil, and that other coil was connected to the voltmeter. So what he did was he turned on the coil 1 and then he went there and then he saw, oh, what is the voltmeter reading? Oh, what is the ammeter reading? 0, 0. Oh, bad. Then again he will do some changes, again he will turn it on, turn it off, again he will go there and again he will see, oh, what is the reading? Voltmeter 0, ammeter 0. But that day he realized what is the mistake he is doing. The reading was 0, that was correct. The problem was electricity is not produced when there is magnetic field. Remember this. Electricity is produced when there is change in the magnetic field, when it changes. So when that volunteer apprentice had suddenly turned on the switch there and Faraday happened to be on the other side, when he just turned it on, there was a sudden change, fluctuation, and that's what he saw. Then he realized it's the change which causes electricity and not a constant magnetic field. I hope this is clear. I hope this is clear. Okay, so there are different versions of the story. So depends, guys, because that time there was no YouTube and there was no camera as such. So history is little bit questionable, but this is the vague story. I hope this is clear. So guys, I saw some kind of fight happening out here. So guys, please don't fight among yourselves. Be cool, chill out and focus, guys. Okay, so you have come here to learn. Focus on the session. All right, very, very important. And he saw is the change in the magnetic field. Look at that. This is the red one is the coil. The green ones are the magnetic field. This is called as the primary coil. This is called as the secondary coil. Primary coil has the actual current and actual magnetic field. This is not connected to the secondary coil. Some of the magnetic field lines pass through it. Do you see that? Some of the magnetic field lines pass through the second coil. They are piercing through it. When this magnetic field changes, suddenly there is a current. But when it is constant, then there is no magnetic field. That's what it is. Yes. Yes. Very true. I'm very good. I'm very good, guys. Yes, Tanmay, you're a little bit late, but it's okay. Join in, no problem. Yes. So now we are going to see Saurav. Don't worry, we are going to see Faraday's law of EMI. Yes, don't worry. Yes, Ankit, we are going to see Lenz's law as well. Whatever you said is going to come in Lenz's law. Now, what Faraday found was, I'll show you all his experiments. Whenever you move a magnet or wherever you turn on or off a coil, you will see the number of field lines passing through a coil will change. Look at that. When the magnet is being moved, do you see through this coil, the flux is changing because the field lines are changing? The shaded ones are the number of field lines actually piercing that coil. I hope you see that. When you move it closer, the flux is changing. That flux change is what causes electricity. And by the way, the direction of current also depends on whether the flux is increasing or decreasing. We'll come to it in Lenz's law. That is what he saw. And if he moved the magnet faster, the change was faster, the flux change was faster. That means the electricity produced was also more. This is what Faraday found. This is what Faraday found. Yes, Simran, it is also helpful for KVPI essay as well. And he saw that if you reverse the poles, then the direction of current also changed. If you move it faster, the current was more. If you keep the magnet at rest and move the coil, then also electricity was produced. If you move the coil and move the magnet together with the same speed, then no electricity was produced. All these were his observations which led him to believe that it's only the change in flux which causes electricity. And he tried doing this also. Like I said, he moved the coil, and moving the coil also created electricity. Understand that. That's very, very important. So guys, let's see whether you have understood this Faraday's law. I have 3 basic questions for all of you. The following diagram shows a coil of many turns of copper wire near a magnet which has some north pole and south pole. The coil is moved in the direction of the arrow mark as shown. How would the current in the coil be altered? Some current will be produced in that coil if this coil has twice as many turns as before. What do you think will happen to the current? Devta, there is a separate session by Shimon sir at 9 o'clock. Maybe you should attend it. But as far as I know, that criteria has been relaxed. Okay? All right. All right. A lot of you are saying A. Very few people said D. Okay. So, well, many options cannot be correct. Only one option will be correct. So, guys, I think it becomes double. Now, why should it become double? Think about it. If the same coil, if you are having 2 turns parallel to each other, the same field lines will pass through the coil twice. If you just have one coil, they'll pass once. But if you have 2 coils like that, they'll pass twice. If you have 3 coils like that, they will pass thrice. So what will happen every time the field lines pierce? They will create flux. So if you have 2 coils, there will be twice as flux. If there is twice as flux, the change in the flux will also be twice as before. So hence the current produced will also be double. Understand that. I hope this is clear. I hope this is clear. Everybody understanding this? Everybody understanding this? And guys, if you have internet problems, you can do one thing. Play the video in 480p. Lower the resolution. Lower the resolution. Check if anybody else is using the internet and stop any other program which can use the internet on your mobile. That's all. Yes. So more the coils, more the change in the flux, and less the coils, less the change in the flux. That's the answer. Here's the next question. In which of the following cases does the electromagnetic induction occur? In which of the following cases do you think electromagnetic induction will occur? one or more options may be correct. Think about it. Read the options carefully. Think about it. Yes, Ankit, every person is serious. In fact, even I am serious about all your preparations. Don't worry. We are there for you for JEE 2022, 2023 and everything. Don't worry. Just have faith, Ankit. Come on, now focus on the session. Come on, come on, come on, come on, come on, come on. Okay, a lot of you are saying BD. Some of you said ACD. All right, all right, all right. No problem, Princey. I think your internet has gone. Okay, some of you are saying just C. Okay, so the correct answer is actually A, B and C. Very few people, I don't think many of you got it. Some of you got a little bit of this. So here is the thing. The current is started in the wire and it is held near the loop of a wire. So guys, think about it. If a current is started in a wire and you have a loop, what will a current carrying wire create around it? Magnetic field, correct? So imagine this is a wire carrying current, it will create magnetic field. Those magnetic field lines will pass through that loop. Now understand, before you turned on the switch, nothing was passing through it. But when you turned on the switch, when the current flows, suddenly magnetic field lines will flow through the coil. So what will happen? Change in flux. And what does change in flux do? It will create electricity. So hence option A is correct. I hope this is understood. Next option. Current is stopped in a wire which is held near a loop of a wire. Now this is a current carrying wire. It is creating magnetic field around it. So some of the field lines are passing through a loop. Now imagine when you stop the current, these field lines will disappear. Again there is change in flux. Understand, when you increase or decrease, anytime there is a change in flux. So moment the field lines go away, there is a change in flux. So again there will be electricity created, but this time the electricity will be in the opposite direction. So I hope you understand, even B option is correct. Option C. A magnet is moved through a loop of wire. This is obvious. I just told you, if you have a loop of wire and you move a magnet through the loop, the field lines piercing through it will continuously change. Flux will change. Hence, electricity will be created. Option D. A loop of wire is held near a magnet. Nothing is being done. You just hold a loop near a magnet. You are not moving. So what will happen? There will be no electricity created. I hope this is clear. I hope this is clear. Okay, yes, very good. So let's get going to the next question, guys. The induced EMF produced when a magnet is inserted into the coil does not depend upon what? The induced electricity produced when a magnet is inserted inside a coil does not depend on which of these following things? The induced electricity, EMF. Come on guys, come on, come on, come on, come on. Rohan, focus on the session. Come on, come on. A lot of you are saying C. Guys, come on. More than one option may be correct. You never know. More than one option may be correct. Come on, come on. Think about it. All right. Many of you are saying C, D. Some of you said AC. Hello, Mr. Best. Join in. B, A, C, A, B, C, D. All right. The correct answer is only B. I just confused you a little bit. See guys, does not depend upon. Be careful, read it carefully. Does not depend upon. In fact, the EMF depends on the number of turns. I just told you, more the number of turns, more the flux change, more the electricity induced. So it actually depends on the number of coils. Resistance, no, it does not depend on the resistance of the coil. Speed of approach, I just told you, if you move the magnet faster or slower, that will change how quickly the field lines are passing through it, how quickly the changes are. So speed will definitely depend. The question says does not depend. So you will not mark this. All of the above, no. I know B option, resistance should be the odd man out. I hope this is clear. Yes, understood guys. Okay, okay. All right, all right, all right. So now, Rohan, I am not biased here. Why do you feel so? I'm not biased towards anyone. Okay, so I just mentioning your name because your name was coming many times, many people were talking about you. That's why I'm just saying, take a chill pill, आराम से बैठे रहो and watch and talk. I'm not stopping you from talking to anyone, but just focus. Okay, that's all. Don't worry. All right. So, all right, let's go to the next thing, and that is Faraday's actual law. So, what is actual Faraday's law? Now, let me tell you about it. So, here it is. The induced EMF produced in any coil whenever the magnetic field lines pass through it is given by d phi by dt, rate of change of flux. Phi is the flux, I just told you. D phi by dt is the rate of change of flux. This is the magnitude of the EMF which is produced. So that's all that is there in Faraday's law. How quickly it is changing. So this is nothing but rate of change of magnetic flux. That's all. Now, if this is the induced EMF, there will be also induced current, and that induced current will be how much EMF is induced divided by resistance of that coil. How much resistance is there? That's it. So, induced EMF divided by the resistance of that coil will give you how much current has been created. So, this coil will have electricity in it and there will be some current flowing through it. That is called as induced EMF and induced current. Remember, every time there will be something called as the primary and secondary. This induced effects always happen in the secondary. So if you have a coil through which actual current is flowing, that will create electricity in the neighboring coil because the primary coil's magnetic field lines are going to pass through the secondary coil. So this is induced current and EMF in the secondary coil. I hope this is clear. I hope this is clear. Alright, I hope this is understood, guys. Everyone clear about this? So let's start solving some questions. Here is your first question. Up on your screen, a magnetic field of 2 into 10 to the power minus 2 Tesla acts at right angles to the coil of area 100 centimeters square with 50 turns. If the average EMF induced in the coil is 0.1 volt when it is removed from the field in some time t, what is the value of that time? So basically there was some magnetic field passing through a coil. The coil had 50 turns. You suddenly remove that coil. So obviously the flux will reduce to 0. So that change will create a EMF of 0.1. How much time did you take to remove that coil? Come on, think about it. Come on, think about it. Yes, Saurav, it will be dependent on the flux change, not exactly flux. The change in the flux is what it will be dependent on. Excellent, VK, excellent. Come on. So, meanwhile, I'll start doing the problem. If you want to start doing it on your own, you are free to do that. Come on, let's see whether you get the same answer as mine. So guys, what will happen is that you have that coil of area 100 centimeters square. Okay, so area is nothing but 100 centimeters square, which is nothing but 100 into 10 to the power minus 4 meters square, which is nothing but 10 to the power minus 2 meters square. Now there are 50 turns. So 50 number of turns through it. Okay. And magnetic field B value is 2 into 10 to the power minus 2 Tesla. Okay. And voltage is 0.1 volt. So guys, just use Faraday's law. E is d phi by dt. But this flux change is going to happen in every coil. So there are 50 coils like that. So into 50. So this d phi by dt is per coil. And there are how many coils like that? There are 50 turns like that. So into 50. Now E is nothing but 0.1 volt d phi by dt. Flux change. What is flux change? First of all, think Flux changes, change in the flux upon the time. Flux is field into area. What is the field? 2 into 10 to the power minus 2. What is the area? It is also 10 to the power minus 2. And the change will be this value minus 0 because you are removing it completely from the field, guys. Into 50. I hope this is clear. I hope this is clear. So therefore, guys, T will be equal to, think about it, 2, I think, did I miss any 2 out here? B into area. No, that was fine. So this will be 2 into 10 to the power minus 4 into 50 divided by, T has gone up, 0.1 will come down over here. I hope this is clear, guys. So 2 into 50, 100. 100 into 10 to the power minus 4 is 10 to the power minus 2. And 10 to the power minus 2 divided by 0.1 will be nothing but just 0.1. So it will be just 0.1 seconds. Just check this out. Oh yes, many of you have got this. Very good, very good, very good. So Ankit, nobody knows why this induced EMF is created. Just like, why should current carrying wire create magnetic field? What is the reason behind it? Is there any reason? Achha, I'll ask you more basic question. Why should a charge create electric field? Those are the most fundamental questions which nobody knows the answers to. So every scientist, physicist is trying to figure out what is the causes of all these fields and forces. I hope that is clear. Very good, everyone. Okay, chalo, let's get going to the next question coming up on your screen. So answer was 0.1 second. Now this question is on generator. Let's do this question on generator. Good evening, Jasper. I think you are from my Drishti JEE batch. So how is a generator going to create electricity? It's nothing but there is a coil which rotates in a magnetic field. Now think about it. When a coil rotates in a magnetic field, what will happen? So there are some field lines piercing through a coil. When it rotates, few of the field lines will pass over and below it. So the flux will reduce. Then it will become flat. Then nothing will pierce through it. Then again something will pierce. So you can see flux passing through that coil is changing at every instant. And because of that, electricity is generated. And that's what we are going to see. Yes. So we have a coil of area A having n turns, rotates at constant angular speed omega in an uniform magnetic field B. Express the induced EMF in the coil. Alright, so let's see this, guys. It's not that difficult. So first of all, let me draw that coil. And that coil's area is like this. It has many turns. So I'll just put n number of turns. And there is magnetic field in this direction. And let's say this angle over here is theta. So if I ask you what is the flux at this moment, the answer will be B A cos theta, but that is per coil. So there will be n coils like that. So B A cos theta into n. That n has to come. Next, what is EMF? EMF is nothing but magnitude wise d phi by dt. I'm only interested in the magnitude, guys. Okay, so I need to take the derivative of this. Now think about it. B is constant because it is uniform. A is not going to change. N obviously is a constant, but theta is a variable. Theta is a variable. Be careful about it. And think, how will theta change? Because the angular velocity is given, theta will keep on changing given by this relationship omega into t. Theta is angular speed into time. Theta is angular speed into time. I hope this is clear. So obviously, Ankit, generator will convert mechanical energy into electrical energy. So the water falling on a turbine, mechanical energy, it will rotate it and that will be converted into electrical energy. Chemical to electrical is the job of a battery. Okay, so that's how it is. Now, if you have understood it till here, think about it. If I understood it till here, why theta is equal to omega t? Let's substitute everything. So first, B is a constant, A is a constant, N is also a constant, d by dt of cos theta, but I just told you theta is nothing but omega t. Now, what will be the derivative of cos omega t, guys? So it will become BAN. Cos derivative is sine, but with a negative value. but I'm not interested in the negative value. I'm only interested in the magnitude of the EMF, guys. So BAN sine omega t, but do not forget omega is getting multiplied with time. So omega should also come outside. Yes, omega should also come outside. So the final magnitude of that EMF will be nothing but BA omega n sine omega t. Now this is something which you should remember also. This is something which you should remember also. Now, why is this so important? Look at this beautiful relationship. B, A, omega n, all are constants, correct? Sine value will keep changing, guys. 0, plus 1, 0, minus 1, 0. So think about it. Think about it, guys. How will the voltage change? It will start from 0, go up, go down, go up, go down. Maximum, minimum, maximum, minimum. What kind of voltage is this? Is this a DC voltage? Is this a DC voltage? Okay, so I just blocked these spammers out here. No, Sneha, that's I think the sound of the azan which is going on right now. No song is playing in my house. All right, I hope this is clear. So I just blocked these spammers and Captain Jack Sparrow and Ayush, who have just come here to just disturb the session. All right, so okay, now I hope you understand this is nothing but an AC voltage, nothing else. Nothing else. Is that clear? Alternating current. Yes, Brajesh. Yes, Navansh. Good evening. Join in. Yes. Now, if it was a DC graph, then it would be, it would not change the direction. Here the directions will continuously change. So that's why it's an AC graph. Understand that. So if I put a modulus sign over here, then I should also put modulus here. But that's a matter of detail. But you get the idea that it will be an AC current, and that's how you will see that when you rotate the coil, if you place an ammeter or a galvanometer, you will see the galvanometer once will go here, once will go there, once will go here, once will go there, because the current is AC. The direction of the current is changing and the magnitude is also changing. So AC current is produced using this. All right. Okay, very good, very good. Cool. So how to find cycle of it, Saurav? Remember, angular speed is given. How much is the time period? 2 pi by omega. So that's also the time period of that cycle. As simple as that. As simple as that. I hope this is clear. Cool. Now let's get going to Lenz's law. This is the last part of today's class. Get ready for the last part of today's class, that is Lenz's law. Now, till now we have talked about flux. What is Faraday's law? Now the third part is nothing but what is the direction of this induced EMF? What direction is it going to be? Now here is the thumb rule. The rule of thumb goes like this. The induced EMF is such that it is such that the magnetic field generated by it will oppose the change in flux. That means if flux becomes strong, then induced B field will make it weaker. And if the flux becomes weak, then the induced magnetic field will make it stronger. It always tries to oppose, not the magnetic field. Keep in mind, this is where people make a mistake. It always opposes the change in the magnetic field. So if the magnetic field becomes stronger, it will try to make it weaker because the change is positive. It will try to make it less strong. If it becomes weak, then it will be like, hey, you can't become weak, you have to become strong. That's how it is. That's how it is. Okay, I hope this is clear. I hope this is clear. Great. Now let's actually put it to practice and see how this works. Now just imagine this magnet out here. Imagine this magnet out here, which is entering this coil. Now just think about it. As it goes inside, will the flux inside this coil increase or will it decrease? Because this is North Pole and that is South Pole. Come on, think about it, guys. Think about it. Think about it. Will the magnetic flux increase or will it decrease? Think about it. It will increase or decrease as the bar magnet comes inside. Yes, very good. It should increase. So what will happen according to Lenz's law? The current in this coil should be such that this current's magnetic field will oppose that increase. Now the magnetic field is in this direction, this blue lines, and it is increasing left side. So what will happen? It will try to weaken it by creating a magnetic field there. So use your right hand, point the thumb towards your right side. Automatically your fingers will curl this way, like this. So the current will be in this direction. That's it. I hope this is clear. Very good. Now, if you take the same magnet as it is and move it away, then the field lines which are passing through it will keep on reducing. Less and less field lines will pass through it. Now think about it. Don't say that, sir, it will be opposite. No, think about it. You have to learn how to use Lenz's law. The field lines are passing this way, but they are becoming weaker in this direction. The field lines were passing this way. The flux was here. It is becoming weaker. So what will happen? The current in this will try to strengthen it. So to strengthen it, use a right hand, place the thumb towards your left side, and automatically your fingers will curl this way. So the current in that coil will be that way. I hope this is now clear. I hope this is clear. Everybody understanding this concept? That's how it is. Let's solve some questions now on this. And you can also do it by different ways, guys. I mean, there is one more way of doing it. There is one more way of doing this, and that is basically, just think if a bar magnet is going here, the current should be such that it will create exactly such poles to prevent its motion. Meaning, if you throw this magnet towards it, this magnet will be slowed down. Yes, this magnet will be slowed down. Why will it be slowed down? Because electricity is generated. How is that electrical energy coming? From the kinetic energy of this magnet. So kinetic energy of this magnet gets converted into electricity. So what should happen, guys? The kinetic energy should decrease. And when will that happen? When you throw that magnet, there is a north pole facing towards you. So if the north pole of this coil is facing towards you, they will repel, and that's why that magnet will slow down. That's another way. It's up to you how you want to do it. I hope this is clear. I hope this is clear. Everybody understanding this? Same thing can happen if you move this magnet this side. If you move this magnet this side, again flux changes, electricity is produced. If electricity is produced, where did this electrical energy come from? From this magnet's kinetic energy. So think about it again. This magnet's kinetic energy will reduce. If it is reducing, think about it. Why will it reduce? Because it is slowing down. Why will it slow down? Because this magnet was attracted by this coil. So that's why there will be a south pole which will be created towards it. That's how you can figure it out. I hope this is clear. So guys, it's up to you how you want to do it. But every time, the weird part is, no matter what you do, you throw the magnet, pull that magnet, do this, do that, every time the magnet gets slowed down. Why? Because electrical energy will be created from the loss of the kinetic energy of that magnet. That's what you should understand. So this is how the poles will alter itself when you change the direction. Let's do a question on this. So this is a question. There will be 3 scenarios, and in each scenario I will ask you the direction of current. That's it. So there are 3 scenarios. Come on, the first question coming up on your screen. First scenario, scenario A. What is the direction of current induced in this coil okay, from A to B, B to A, or the magnitude is 0 if the bar magnet is moved towards the left. North is here, south is here. Think about the direction of current, be careful. Oh yes, Kiruto, this is in fact used. This is called magnetic levitation, and you know, briefly, if you are having a big bar magnet wrapped around you and you fall inside a coil, believe me, you will not fall with G, you will fall with an acceleration less than G. Brajesh says if Lenz's law will become false, we can create energy as much as we want, no law of energy conservation. Yes, correct, Brajesh. That's the whole idea of Lenz's law. Okay, many of you are saying A, some of you are saying B. All right, Saurav says B to A pakka. Okay, all right. So guys, here is the answer. Let's apply our minds and think about it. What exactly is happening? This is the North Pole. Okay, so the magnetic field lines will be somewhat like this. Now, this is the direction, by the way. As you move far away, the number of field lines passing through that coil will decrease. So the flux in this direction will decrease, correct? The flux in this direction will decrease. What will be the direction of current? Such that the decrease will be prevented. It will try to strengthen it. To strengthen it, this current will produce magnetic field in that direction. So this will be the induced direction. Now if this is the right hand thumb, think about it, how my fingers are curling. My fingers are curling this way. So the current should go like this, and it should go from A to B, guys. Come on, think about it. It should come like this and it should go like that. I hope this is clear. So answer is A to B. Okay, understood, guys? I hope this is clear. Very good. Yes, so the answer is A to B. Yes, so it will go like this. Okay, so the answer is A to B. Let's get going to the next question, guys. Done, clear, very good. Okay, now here's the next part of that question. What is the direction of the current when you just turn is closed? When the switch is closed, what will be the direction of the current in this resistor? Come on, visualize it properly, think about it. What will be the direction of the current induced just when the coil is closed? Come on, think about it. No problem, Jasper. So Jai, just think about it this way. Just see where is the magnetic flux. See whether it is decreasing or increasing. If it is decreasing, try to increase it using your right hand rule. If it is decreasing, again use your right hand rule and point your thumb in the opposite direction. That's all. You will understand it better in this question. Again, come on, think about it. And you can also watch the replay, Jai, in case you still have doubts, or you can comment in the comment section. Okay, chalo. So guys, here is the answer. Let's think about it. The moment you close the switch, okay, one sec. The moment you close the switch, the current is going to go like this. So you can see the current going like this. So what will happen? Because of that, there was no flux before. Suddenly, because of this, a magnetic field will be created and the magnetic field will pass like this. So think about it. Because of this sudden current, these lines have come new and these lines are cutting through that coil over there. You can see that coil A, B, and there is a semicircle. So the flux here increases. Flux in this direction increases. So what will happen? The flux will be weakened according to Lenz's law. So hold your thumb in the opposite direction. To weaken it. Automatically your right hand fingers will curl like this. So the current induced will be like that. So it will go from B to A. Answer is B. I hope this is clear. It is not 0. Understand that. Okay, so it is B to A. I hope this is clear. Anand, this Whole idea was, why I don't share my writing, because we want you guys to make or put in that effort for actually understanding things. Over the past few years of my experience, I know if you provide everything ready-made, most of the students don't read, and when things are automatically fed, spoon-fed to you with these notes, then nothing enters your head. So what we do instead is we provide you this blank slide, plus you have YouTube, you can always watch the recordings. So we want you guys to use these session PDFs as actual workbooks where you can actually write it down, all right, on your tablet or take a printout or whatever, and then see the difference. Things will enter in your head beautifully. That's the whole thing. And Anand, let me tell you one more thing. We are giving you entire chapter extracts. Do you know that? Do you know that we are giving you entire chapters formulas? That is already being provided as notes in something called as extracts. So summary is already being provided. Only the session PDFs is what we are giving you. I hope it is clear. So we are actually giving you all the notes in something called as extracts. Okay, so don't worry about it, Anand. Okay, so here is the next question, and here it is. Come on, figure out if this is the current carrying wire, and what is the direction of the induced current when the current in the figure is decreasing rapidly. This current carrying wire, straight wire, this current is decreasing. So what will happen? Think about it. Very good. Come on, think about it. So Mr. Best, where will you find the extracts? There are two places where you can find the extracts. Number one, you will find it on the Telegram group, or you will find it in the last lecture. Let's say there are 4 lectures in one chapter. 4th lecture's description box. Understand that. Last lecture's description box, you will find it. Okay. And if you don't find it for any chapter in physics, please let me know. I will make sure that the content team will upload it. Don't worry. Okay. Cool. Okay. So let's see the correct answer, guys. So the correct answer is, let's think about it. Here, this is the current. Come on, think about it. Use your right hand. The current is flowing in this direction, left side. So see how your fingers are curling. So the magnetic field is like this. This is the direction of magnetic field. Some of these field lines will pass through that coil. Think about it. Some of these field lines are going to pass through that coil out here. Now this current is said to be decreasing. So what will happen? What will happen? These field lines which are piercing through the coil like this inside the plane, they will also become less and less. So the flux which is pointing inside is going to become weak. It's going to become less and less as the number of lines piercing through it is weakening. So what will happen? What will happen? You have to make it stronger. How do you make it stronger? By creating induced magnetic field in this direction. How do you create induced magnetic field in that direction? Use your right hand, point it inside, see how your fingers are curling. See how your fingers are curling. It is curling clockwise. So the direction of induced current will be like this, A to B. Option is A. I hope this is clear. I hope this is clear. So Preetham, the thing is, instead of my writing, I am giving you the printed notes, my dictated notes in extracts. Understand that, beta. And if you still want PDFs, you can always take screenshots of this. And over the past few years of my experience, it tells me that there is nothing better than your handwriting notes. If you don't believe me, you can try it out reading from somebody else's notes and make your own notes and see what is the difference. So guys, I can do that. I can just, what difference does it make? I'm not going to charge you for that. I can just share all my notes. But I know it's not going to benefit you and it will be useless. I know that. I know that. And I know many people do that, give handwritten notes and all that. Yes, that's their methodology. But I believe personally giving my own handwritten notes is of no use. So that's why instead of that, I give my printed notes. So I give you my printed notes plus this session PDFs are there, plus my teachings are there on YouTube, plus I'm available on pro subscription, everything. You have to do that research and make your own notes. That is the only way to success. There is no shortcut, beta. Is that understood? Rohan, that will be of no use. Understand, beta, that's of no use. It will be like I'm cheating you. Do you want me to cheat you? Obviously not. Understand that. It's not about managing. It's not about managing, beta. You will see that there is no effect. Okay, I'll give you an example. Rohan and others, do you know how to cycle? Do you know how to cycle? Yes, do you know how to ride a cycle? Mrinmay, yes, I'll tell you. Do you know how to cycle, guys? Yes, Mrinmay, first answer this question. Mrinmay and Rohan especially and others. Yes, everybody knows how to cycle? Acha. So guys, please tell me, did you in your younger days learn how to cycle when you saw others cycling, or when actually you cycled and you fell down few times or lost balance and that's when you learned cycling? Which one was it? Please tell me. Did you see others' videos? You saw videos, oh, he's cycling so well. Oh my God, look at that guy, he's performing such nice stunts. Wow, watching these 10 videos, I will definitely be able to cycle. That's how you learned cycling? Or did you actually sit on that bike, fell down few times or lost balance, and that's how you learned cycling? That's your answer, guys. That's how it is. Probably you won't remember it because it's been quite some time now, but that's how it is. Same thing happens. If I give you ready-made things, you will not learn. You feel that you have learned, but you will never learn. I hope this is clear. Okay, Saurav had some funny answer. Saurav saw something. Looks like Saurav was just kidding. It's okay, chill. Okay. And by the way, the same thing is true about swimming, guys. Some of you know swimming. When did you learn swimming? By seeing others swim or by using a float? Tell me. Did you guys use a float when you learned swimming? Yes, initially. But did you learn swimming when you used a float? No. When was the exact moment? Tell me that exact time when you learned swimming. It's not when you are using that float, guys. It was that time when you removed that float, that balloon, that tube, whatever you are wearing, and you went into that deep water alone. That's when you will learn swimming. And when you try to swim, and then you will struggle, you will put in your best. You will use your hands, legs, move your body, you will struggle, but you will come up, you will not sink. And that's when you learn swimming, guys. Isn't it? Isn't it, guys? So, do you believe in whatever I said? Do you believe in whatever I said, and do you understand why handwritten notes is of no use unless and until those notes are being made by you? It's a big gimmick. Yes. Yes, that's very important. So extracts are there. So use our extracts and you can revise everything. Alright. So that's it for today, guys. And these are our homework problems for today. So this is the first homework problem. Okay, this is our first homework problem, and this is the second homework objective. Oops. And this is the third homework problem. So 2 objective questions and 1 subjective question. This is your homework for today, guys. Tomorrow I'll be meeting you. All these homework problems will be available in the session PDF. This one, and this one. All of them will be available in the session PDF. I'll be posting all the solutions in the Telegram group. Extracts, the entire summary of this chapter will be provided at the end of the chapter. Don't worry about it. Alright. So guys, do not forget to join the crash course. In case you have not checked out the details, please check out all the details of the crash course, because there is an offer running of 20% off. Alright. Because you are attending all these YouTube sessions. These are live classes and you are going to get amazing teachers. I know these teachers, they teach really well, and you are going to have 20 test series, and there are going to be amazing tips and tricks sessions. So do not forget to check it out. And also the Ekalavya batch entrance test, which is on Thursday, which was actually today, and then Sunday. That's the last entrance or entry point for the Ekalavya batch. So in case you have not checked out any detail about it, please go ahead to the Telegram group, check out all the details of the Ekalavya batch for the JEE Advanced 2021. Fill up this form. This is the last entry point. Okay, I hope you have enjoyed today's session, guys. And remember, you not only learn about physics over here, but you're also going to learn life values out here. It's not just about learning physics, guys, because you have to learn a lot of things apart from physics in life, and that's what we are going to learn over here. So stay tuned, guys. Take care and have fun and keep learning. Okay, so don't worry, Anand, it's not like I don't want to share. Don't get disappointed. You will remember my words later on. Okay, chalo. Bye bye, guys. Have fun. Take care. See you again tomorrow at 7 o'clock for the marathon session. Bye bye.